Started. So welcome to Coding Interview Crash Course, session 3 in week 4. Today we're going to be talking about linked lists. There's the attendance code. It's conga_line. It'll make sense in a bit, I guess, but given linked lists, it's probably a fitting attendance code. Okay. There's the link to the slides. We've gotten CICC and lessons right, so all about that growth mindset here at ACM. Other important stuff apply to be an ACM intern. You can apply to multiple committees at the same time. Applications close tonight at 11:59, so get on it. There's a link to the Facebook event and the actual application. I highly recommend the experience, and it's a great way to meet new people and give back to the CS community here at UCLA. So here's our starting meme. Hell yeah, I know about linked lists, but it's in HTML tags. So that's not a linked list. That's a list of items or whatever. Okay. So just a quick overview of linked lists. So linked list is a collection of items stored at non-contiguous locations. And that's probably the biggest differentiator between linked lists and arrays. So what shortcomings of arrays do you think this would help overcome? Or like what issues did we explore with arrays that potentially are solved by having elements at non-contiguous locations? Easier to insert and delete, yes. And that's basically the biggest help, is that you no longer have to resize or move around a bunch of elements every time you insert something new or delete something and take it out. So we're going to do an example of this later on if it's not super clear as of now, but that definitely helps saving time complexity when you're doing those operations. But the trade-off is, of course, direct access. There's no longer constant time access to particular elements. So to access any element, you still have to look at each node, see if it has a value, and then you can access it, as opposed to arrays, which have that constant time access with indexing. Searching access are both O of n, but insertion and deletion are now O of 1 with linked lists versus arrays. So linked lists can be singly linked or doubly linked, which means that your nodes can either point to one node, the node that comes after them, or two nodes, the node that comes before and after. That helps with traversals in some cases. But in my experience in interviews and the like, I've mostly only seen singly linked lists. Just a quick, I guess, question. Do you say singly linked list or singly linked list? I've been debating this. It kept me up last night for a while, but whatever. Okay. So linked list representations, the C++ standard library has a class which you can use by including list. But again, in interviews, I haven't really used that too much. I've usually been given a struct definition that looks something like this. So this is a list that stores integers. Each node has an integer called val. It takes the pointer next. And there's also this function that you can use to create new nodes that assigns a node to have the value that you pass in, and the next pointer is just null. Okay, singly linked list. There we go. We have some ideas there. Okay, so a common question is just like, why? So how do you explain a linked list to someone who hasn't encountered them before? And the answer is to ask for the 10th letter of the alphabet. And so what is the 10th letter of the alphabet? Okay, well, I think I don't know it off the top of my head, but I can start at A and go to B, then C, D, E, F, G, H, I, and J. And J is the 10th letter. But I guess the point is that it's useful because you only need to know the location or the value contained in the next node, and you can still store a bunch of data, and you can just like keep going to the next node until you find what you're looking for. So that's just maybe some intuition behind linked lists and why they're helpful. Okay, so linked list operations. So the first node in a linked list is typically called the head. You'll get a head pointer. If head is null, the list is empty. For the last node in a list, the next pointer will be null, so it's pointing to nothing. And to traverse a list, keep following the next pointers of the nodes you're at until you reach a null pointer. And this is something to be super careful about when you're coding with linked lists. Always make sure that nodes you're dereferencing or accessing are not null before you actually do access them. Otherwise, you'll get seg faults, and it'll just get really messy. Okay, here's here's another meme shout out. Ariana Grande stream positions. But when you don't find the node you're looking for, just keep on going to the next one. Okay, so we kind of blasted through the theory. Are there any questions that people have about linked lists, about traversals? I think we should have time to do a quick simple traversal and then get into our first warm-up question. As of now, are there any questions, anything people want to see? Feel free to let me know in chat, and I guess we'll take a quick break. Okay. So delete a node. So given a singly linked list and a target value, delete a node containing the target value. An assumption you can make is that if there are multiple occurrences of the target value, only delete the first occurrence. And use the following definition of nodes. So a list node has a value, it has an X pointer, and that constructor or whatever. Okay, we'll take a look at this for a few minutes and then hop onto the whiteboard. Just starting off, are there any questions or other things? Any questions regarding assumptions you can make or okay, I think we're doing okay. So I guess I'll stop sharing this and get on the whiteboard and share that. Okay. Bill, could you enable permissions real quick?
Yeah, sure.
Okay. So I think we'll do a quick traversal just to make sure that we're all aware of linked lists and their magic before we get started. So just traverse through a linked list. Let's say we want to traverse through a linked list and print the nodes. Chat, do you have any suggestions as to how we go about that? Okay, no worries. So basically, assume we're given a head pointer. Yeah, that's basically it. So we'll assume that we're given a head. And remember, I think critically, while as long as we're not at null pointer, just print out everything. So while, I guess we'll declare a current pointer, so list node. And while current is not null, just print out whatever is there. Okay, so I think that's a simple traversal, and this should work. Not really going to compile it. But I think now we can jump on to our deletion question. Are there any questions on this before we move on? Oh, yeah, there we go. Yep, you want to print out current dot value, make sure it's
Arjun,
dot null pointer. Yeah.
you are missing one very important thing.
Oh God.
Sorry for putting you on the spot, but it is very important. It has something to do with the while loop.
Oh my God. A great catch.
Thank you.
So this program that we just wrote goes right into an infinite loop because we never move on. So this is super important, and it's easy to miss. I just did, so don't do what I did, and make sure you move. You keep on swimming. Go to the next pointer. This should work. Okay. So yeah, let's move on to our deletion question. And so we're given the head pointer and a target value, and we want to delete it. We can return void, doesn't really matter. Okay, so if we're given this list and the value 3, it's super helpful to think about. It's super helpful when doing list stuff to like draw it out and then do it. That's something that's worked for me. So if we're given the value 3, it's this value right in the middle. Basically, what we want to do is get rid of this connection and connect 2 to 5, basically, right? Is there anything else we have to do? I don't really think so. But it's this connection that we sort of want to get rid of. And another interesting case that comes up is, what if we want to delete the value 2 in this list? So I'm going to draw that real quick. Oh wait, I can't edit the whiteboard anymore.
Arjun, there's a question in chat. What about the connection between 3 and 5?
Oh yeah, so we need that's another important thing, that you have to delete the node that you're getting rid of, and so that there's no memory leakage, basically. So that's something super important that you have to keep track of. And so as we have it, when you delete the node 3, you also get rid of this connection, and that goes away. Okay.
I just like to add on to that. I think this is basically all you need to do for deletion, because you're only keeping track of the head pointer, so you're only keeping track of like the pointer that's pointed towards like number 2.
Mm-hmm.
And when you traverse through that linked list, you're going to go 2, and because like 2's next, like the next pointer is pointing to 5, it's going to go 2, 5, and then to the null pointer. And 3 is just going to get ignored. So essentially, we've essentially deleted it.
Yeah, and critically, we delete it without really affecting. So 5 is completely unaffected because 2 points directly to it. It's affected. But if there are like a million nodes after 5, they're completely unaffected by us deleting the node that contains 3. And that's sort of where this advantage comes in of not having to resize all the time. Okay, so if we want to delete 2, um, since 2 is head, there's nothing that directly points to it. So that's just another little subtlety to keep track of. So we'll just sort of keep track of node 2, set head to number 3, and then delete this. Similarly, when we're done here, we're going to delete this, and this will also go as a result of that, and this will also go. Okay. So is that sort of general idea clear? Is there anything to go over in that? Ooh. What happens to 3 in memory? Since we only delete pointers, does 3 become spaces? Okay, so yeah, this is when you delete a pointer in C++, you delete the memory that it points to. So the 3 gets like obliterated. It doesn't, I guess it does kind of become space dust. It's not like, it doesn't just hang out there, it's gone. Oh, I lost whiteboard editability again.
This is unrelated, but is space dust a reference to history of the world? Yeah, I thought so.
Okay, I still can't edit the whiteboard. Okay, I swear I just lost editing permission again. Yep, just got it back. Okay, so I'm gonna make another text box, I guess. Maybe I'll delete this stuff up here. Okay, so we'll create a void method. We don't have to delete anything. I mean, we don't have to return anything. We'll get a pointer to the head. We'll assume we have a target. And as was said earlier, if there are multiple occurrences of target, we can just delete the first. So that's not a worry. Okay. So we're looking at the 2 cases, and the 2 cases that we had were if we're deleting head, and if we're deleting something else. So I think the critical factor that was pointed out is that it's super important to keep track of the node you're deleting so that you can delete that and not just like have it blocking. We want to make that node that we're deleting space dust and not just like have it sort of sitting there and just like hanging out forever. Okay, so if we're deleting the head pointer or the value contained in the head thing, it's going to look something like this. So if head, so if the value contained in head is target, then okay, we're going to have to do something. What we're going to do is declare a new node. And we'll call this target node, or maybe we'll call it, yeah, we'll call it target node. Nothing too morbid. This is safe space. Okay, so now we want to set head to be the target node, to be the next node pointed to by the original head, which is also just target node. So head is equal to target node. Next. And now we want to make sure that we delete the memory that was contained in the head. So we're gonna get rid of that real quick. Okay, and when you delete target, this is something important, I guess. When you delete a pointer in C++, you like free up the memory that was pointed to by that pointer. So it's not like there's just like that blob of memory doing nothing. Okay, so is that fairly clear? Is it kind of understood why we have to get rid of, why we have to keep track of target node as well? Okay, I'm going to assume that it is. So now I guess if we're here, so if we're deleting another node, how do we get to that node? Okay, I don't see too much, but yes, just keep looping. So we're going to have a loop, and basically, we're going to declare pointers real quick for traversing. I'm going to call it P. Semicolon. Okay, and now I think the biggest thing to think about is, when do we want to stop traversing? Like, do we want to stop traversing when we're at the target node, or do we want to stop traversing when we're somewhere else? Right, we want to stop right before target. And why is that? Okay, yeah, I guess it's a little, but the critical point is that we want to stop right before target, and that's because if we reach, yes, exactly, because we want to have our current node point to the node that comes after the thing being deleted, and we'll lose track of that if we stop when we're at the thing being deleted. So we want to make sure that we stop before and not as opposed to stopping at the node whose value is target. Okay, so I'm going to code that up. Just simple if statement. So if so if the next pointer of whatever is not null, and the value contained in the next node is the thing we're looking for in the next one. Okay, so what we want to do is spaces to indent. We want to just jump out of the loop once we get to this point because we're done traversing. Now we're out of this loop. And now what we can do is just make sure that we're not null. And again, declare a temporary node. I think I did it again. I forgot to set P to be P next.
No worries. You got it this time.
Growth mindset. We're all about that growth mindset at ACM. Okay, I think I'm going to either scooch this up or figure out or zoom out maybe for a minute.
Or you could just move like the text up.
Oh wait, yeah.
I think everyone's sort of seen how to delete the head.
Okay.
I don't get it.
What's up?
I don't get it.
Which part?
The part that's about to be deleted.
Oh yeah, I didn't catch the last thing that you said.
I don't get the first portion of the program.
You mean if we're deleting head?
Yes.
Oh, okay, no worries. So I guess the thing is that if we're for general nodes, what we're doing is we're stopping at the node that came before the node we're deleting. Does that make sense? But head is like the first pointer, the first node in our list. So in this diagram, this would be head. So head would be the arrow, like that pointer. So the point is that there's like no node before the first node. Like, does that make sense? Because so we can't really stop at anything because like there's nothing before it. And that's kind of why it warrants its own like special case. Does that
I don't understand what's going on in the code.
oh, okay. Um is the question clear? Like if you have a linked list, you want to delete, like if you have a list of values, you want to delete the value that you're given. Is that good?
Yes.
Okay. So now you have this struct, and it's like we have our list of values has to be like represented in code and has to be represented to C++. So to do that, we use a struct, which is like a container, basically, a little class. And so what we're going to say is, I'm going to represent this list, and each item in this list is going to have a value, which is an integer, and it's going to have a next pointer. So it's going to point to the next thing in my list. And for now, I guess you can ignore the third, excuse me, the third line in here.
I just want an explanation of the code.
Okay. So like we have to delete a node.
Wait, is there like a specific line you're confused about?
everything in the section if we're deleting head, just like the code. I just want to understand what the code's saying.
Okay. So if we're deleting head, the value contained in head is going to be target, right? Okay, so now what I'm going to do is I'm going to declare a temporary node and keep head in that. I guess I'll draw it out maybe. So for now, this is going to be temp. This is going to be target node. So target node is going to point to this. Now what I'm going to do is I'm going to set head to be target node dot next. Target node next. So target node next is this pointer which points to this box containing the 3. So I'm going to set head to be that. And I'm doing that because I want to get rid of this first node. So now head is going to point over here.
Okay, I see now.
Okay, my bad. And then we're going to delete target node and we're going to yoink this into oblivion and we're going to get rid of that as well. But I guess the point is that like since there's nowhere before it to stop, we just want to do that. And I guess it warrants its own case because it wouldn't fit in properly over here. This code, all it's doing is like declaring a temp node basically. And we're declaring a temporary node to keep track of the node we want to delete so that we can successfully delete it and free up that memory, but also keep track of what it's pointing to so that we can assign head to that. Okay, so I guess we'll jump back. Is delete and delete target node an inbuilt function? Yes. Delete is a C++ keyword. And if you delete a pointer, it sort of frees up the memory pointed to by that pointer. Great question. Okay. Ooh. Okay. I swear to God, one day I'll be able to return to a block of text. Okay, but in the meanwhile, we're in this if statement. I'll get rid of that real quick. Just a sec. Okay. Oof. Here we go. Okay, so we're in this temp. So we declared another temporary node, and we have it pointing to the node we want to delete. So what we're going to do is we're going to set the next pointer of P to be our target nodes next. And does that make sense? Okay, I'm going to assume that it did. So I'm going to set P next is target node next. And now I'm going to delete target node. So what we kind of did is basically the same thing that we did for the head node. We're setting up a temporary node. Then what we're doing is we're assigning the pointer. So we're taking the previous node, pointing it to the next node of the thing we're going to delete, and then we're deleting the thing that we wanted to delete. And after this, we're all done. So just like spam a bunch of closing braces and have your IDE of choice fix that up for you. Don't we need a return statement after the first case? Yes, you probably do. I'm going to slide that in. So that we don't end up deleting it twice or just like coasting through there. Okay, so this is, this probably works. And I think we kind of did step through it. We we step through the deletion, we declare a temporary node, do all that playing around with the pointers. Here is our traversal. So while p not null, we want to make sure that we stop right before the target, and then jump out of the loop if we actually do find it, do that deletion, and we're out of the woods. Okay, so are there any final questions? Otherwise, we're mostly done with this. Okay, cool. I'm going to take that as a no. So I'll stop sharing my screen. Alvin, do you want to do the next one?